Welcome back to Popular Science Radio. I'm Alan Taylor. Popular Science brought to you in part by Meguiar's. Since 1901, the world's finest surface and car care products and accessories. Meguiar's. I'm Alan Taylor. Dr. Kort Stoskopf on the phone. In studio is master builder Carl Champley. And we are going to talk now to David Paratore, President and CEO, NanoSteel, the future of steel, stronger and weighs less, which for cars makes perfect sense for better fuel economy and still strength in a crash. David, how you doing?
Very well, Alan. Thanks very much. Good to hear from you.
Thanks. Well, now tell us about this because my world is revolves around the car industry always, and I'm very interested in this because I can only imagine it's going to be great for the car business.
Yeah, that's definitely the idea. We've been working on this for, in total, about 18 years. So,
wow.
NanoSteel, a company, is only about 10 years old, but the Department of Energy and DARPA and the National Lab System worked on it for about 8 years before we took over the technology and brought it to where it is today. In essence, what it is a new type of steel that gives you really high strengths that they've not seen before, or people have not seen before, but with a high level of ductility, which means that you can bend it into shape.
Yeah, wait a minute. So ductility, has anything to do with duct tape?
I don't quite think so. Duct tape you use, you want to seal up those ducts when you're doing air work. Ductility is another word for ductility is bendability.
Okay.
How well can you shape this stuff? Because as you can imagine, the stronger you make a piece of steel, the harder it is to bend it.
Well, I know that that Corvette, the Chevrolet Corvette, has a water. What do they actually fill tubing with water, and they shape the steel tubing, and or whether maybe it's aluminum, I don't know what it is, but they use water. It's hydroformed.
Yeah, it's called hydroforming.
Right.
It's another way to get complex shapes or really a lot of different shapes just by using the pressure of water. Because as you probably well know, when you use water or a fluid, you can get a nice uniform pressure across the whole surface.
Right. I'm sure Dr. Kort has a question for you.
Well, actually, I'm fascinated by it because, like all of us, I love, we're in an age of materials that just the way we're taking all the stuff, that we used to have way back when and how we're learning so much more about it, and it just makes it that much better. And this obviously, like, for example, in aircraft, they use titanium simply because they couldn't get the strength-to-weight ratio that they needed, so they had to go to these other things that were horrifically expensive and difficult to work with. This is fantastically interesting. Does the nano part of the name of it have anything to do with the way you've achieved what you're doing?
Exactly. The reason we're called NanoSteel is because the microstructure, which is basically the crystals or the grains that the material is made of, are average in length of less than 100 nanometers. The way I like to explain this is if you're familiar with a granite countertop, most of us have seen those at some point, you can see all those crystals in the countertop. If you were to take a piece of steel and take some etching and etch the surface off, you would see the same kind of format, all these crystals all butting up against each other. And for a long time, people have realized that the smaller you make those crystals, the smaller you make those grains, the stronger the material.
Interesting. So does it weld kind of, obviously it'd be a little bit different, but is it weld kind of the same way as regular old steel?
Yeah, see, that's one of the beauties of what we've been working on, why it's taken so long, is that we are making sure that the material that we bring, which is steel, can be formed the way you're used to forming steels, can be welded the way you're used to welding steels, essentially keeping it easy for the guys who have to make the cars and form the parts to continue to use the technologies and the processes they've been using for decades.
Wow. This is one of those discoveries that I obviously you guys have known about it for a real long time. I love this because it's going to change our lives. It's not going to be like, I don't want any of that old stinking steel. I want NanoSteel.
I completely agree. People have, a lot of us take steel for granted. You can't really walk 2 feet without bumping into a piece of steel somewhere. It's one of those, I always call it a quiet $1 trillion industry. It's a massive industry, and everyone just kind of goes about their business in it. And there's not a lot of press about it because it's kind of an old technology. But
what do you want to do with this? What is your goal? Is it to build cars, skyscrapers? What is your goal?
Great point. The most the largest advantage for something like NanoSteel is to make cars lighter. So when you look at that industry and you look at all the effort that's going into making cars more fuel efficient, and the new CAFE standards in the United States are fuel efficiency, there's a real struggle going on in that industry because you can do only so much with batteries and different hybrid systems. If the cars remain heavy, you really have an uphill battle, so to speak, with trying to make them more fuel efficient.
Just think what it'll do to the shipping industry.
You could do the same thing with shipping. Yeah, there's no question.
Will your NanoSteel replace chromoly, for example? It's used in a lot of applications because of its increased strengthening, but the ability to use it is so difficult because of the way.
Well, and I like the duct tape ability of it too. I think that's kind of cool.
Yeah, chromoly is definitely one of the is certainly a really good material, and it's going to always have its niche, just like most materials have their niche. I think the difference is that when you look at the steel industry and you look at the auto industry, they're at that point from a maturity standpoint that they're looking at some what we would call exotics, carbon fibers, aluminums, all good materials, but really hard to do in high volume. And so if you can make steel work, make it super strong or make it really strong and keep it so that you can reduce the weight, then it makes it a lot easier for the auto industry to continue to use products and technologies they know.
Well, and the whole advantage of chromoly was its strength, the weight, again, that you could do it. But again, so few people actually knew how to work with it that you could actually end up with a roll cage or something that if you didn't do it perfectly, you actually ended up with something that was less good than even regular steel just because it could explode. And so if your steel ends up, how much stronger
don't ask any more questions till the other side of the break. All these inquisitive minds. One question I want you to think about, David, while we are in a commercial break is I want to know what you've used it on and how you've tested it so far. So we'll talk more about NanoSteel on the other side here at Popular Science. 2 minutes, and we're back. Popular Science Radio. Hang with us. Welcome back. It's Popular Science Radio. I'm Alan Taylor. Show sponsored by Shell with their nitrogen-enriched gasolines. All three grades now have 20% more nitrogen-enriched gasoline, and or I should say cleaning agents in the gasoline, for even more protection from performance-robbing gunk. Fill up and see for yourself. No other gasoline protects better. Yes, now with 20% more cleaning agents. Popular Science, building a better world on the cover, this month's issue. We're talking about, though, NanoSteel, new, lighter, stronger steel. And David Paratore, he's the president and CEO of NanoSteel. You can find out more information at nanosteelco.com. So nanosteelco.com. Let's talk about this, what you guys are going to do and how you're going to do it and where else we'll be able to find it. Like Court said during the commercial break, he says, I want to buy some of this stuff. What if I can find it over at Ace Hardware?
Can I ask a question first up?
Yeah.
What is the difference in weight?
If you go one step further, the density is the same. So it's just like all steel, 7.8 in terms of density. But the ability of strength allows you to use a thinner gauge.
Right.
So if you were using, say, 900 megapascal strength, it doesn't mean the units don't mean much. But if all of a sudden we can give you 1,200, you're saving 30% of the weight because you can thin the gauge down by 30%.
Oh, absolutely. You don't have so many headache points in a house construction or a high-rise where you've got that deep beam. You've got a much narrower beam. So
that's what I say. Carl, just so you know, David, Carl was in Australia, a
structural guy,
big building builder with steel buildings and all this. And so I thought to myself, wow, this has really got endless uses. But now, where are you in this process? I see you guys have had more than 300 licenses and patents and patent pendings and all these things in the portfolio. But where are you? Why aren't we using this in cars right now?
The breakthrough for this type of steel happened less than a year ago, just about a year ago. So prior to that, we sold our first-generation products, and we still sell those today as a coating. We use them in mining and in oil and gas and drill pipe, basically to protect the surfaces from wear resistance. That's what I'm really good at.
Yeah, and I asked before we went to commercial break, where is it? You just gave us some examples of that. You talked about the breakthrough. Have you ever seen that episode of Seinfeld where Jerry Seinfeld and Kramer were watching a surgery, and Kramer was eating Junior Mints, and he dropped one, and it went into the body of... So was it a Junior Mint? Was that the breakthrough?
I'm sure our chief technology officer would like to think it wasn't, so I'm going to say no. But yeah, I think that with any breakthrough, you have a lot of smart people and quite a bit of luck before you get there. So it's a combination of both, I think.
Was it like plastic where you guys accidentally discovered this new way? Did you set out on a journey? We're going to make steel lighter and stronger.
Oh, yeah. Without question, this has been the focus for 10 years. And about a little over a year ago, one of the large auto companies came to us and said, okay, when you can make this type of steel, now you got our interest. And so we set out on a really strict, defined path as to what to try to achieve for them.
So, and you ultimately want to be in the auto industry with this?
Yes, without question. The idea is to take this steel and bring it to automotive.
Now, what happens if you get to that point where, you know what pot metal is?
Pot metal.
And the reason why I say this is
that
because
a band?
No, when you get a little something that's really cheap, and it typically it's made out of
some granular material that they jam into molds to make cheap figurines.
Yeah,
and all
exactly.
Like powdered metal.
Yeah, it's horrible. So the question I have is that if pot metal is the worst, is NanoSteel the best in your guys' world? Would you say?
Yeah, I'm without being overconfident, I would say that we're about to offer properties that steel has never been able to do before. So in that light, yeah, we are. We're going to make it a lot easier for people to continue to use steel in cars.
That's great,
and that's really the goal here. If you
can it be recycled?
Yeah, I was just going to say that. If you look at all the advantages of a material, when someone decides on a material for something as big as a car, meaning for an industry that big, there's so many factors. Can it be recycled? Can it be welded? Can it be painted? Is it easy to actually shape into parts? So you have to take all of those things into consideration when they make a determination as to what material to use. That's why being able to advance the technology in steel is so valuable.
All right, here's another one. I wanted to be a welder in high school. When I went into college, junior college, I went and took some welding classes. Does it emit any poisonous gases when you're welding? I mean, I got to think of all these obscure questions, but I want to know more. I love this. Otherwise, if I can't find any drawbacks, then I'm digging on it heavy. Where's the drawback?
From a weldability perspective, when you have those kind of fumes and stuff, that's because something in either the material itself or the material you're using to weld to it is burning out and using gas. No, these are conventional materials.
It's the same old poisons that are around whatever you're welding.
Right.
Yeah, pretty much.
We're used to that.
I wouldn't use that word, but yeah, it's the same old kind of emissions that you would have today.
There's going to be those issues no matter what. I had a question. If you just had to compare your steel to common garden variety now, and so that I don't have to go out and buy my new load and resistance factor design book, what's the factor that your steel improves it? Is it
you got 20 seconds to answer that before we get run over. Go ahead, David.
Okay, so 2 to 3x.
Oh,
2 to 3 times.
Wow. Oh, that's fantastic.
All right, so any of you guys in the auto industry want to know more about this, you can contact David Paratore. He is at nanosteelco.com. David, sounds like you're going to be a very wealthy man or a very bald man from pulling your hair out trying to get this to market. David, thank you very much. It's NanoSteel on Popular Science. We'll be back.